Hello viewers, in this video we are going to discuss the nature of roots of quadratic equations. So I want to remind you that the roots of a quadratic equation, which are the solution to the quadratic equation, has so many natures in the sense that one root can differ from the other in terms of each nature. That is what we mean by nature of the roots of quadratic equation. The roots of quadratic equation can be one of the following. The roots of a quadratic equation can be real and equal. It can be real and distinct. It can be imaginary. What do I mean by real and equal? It is real and equal whenever you get two different values that are real numbers satisfying that given quadratic equation. But it is real and equal whenever you solve the quadratic equation and you find out that the two answers you are getting are the same thing. Then sometimes you can have no value that can satisfy the given quadratic equation. You are getting a complex value. In that sense, we say that the root of that quadratic equation, the roots are imaginary. And if you want to plot this on a Cartesian plane, look at what you have. You find out that the curve will be above the x-axis or below it. It will no longer be touching the x-axis, because wherever the curve touches the x-axis gives you the solution of that given quadratic equation. So no real values of s can satisfy the given quadratic equation. Now, when it is real and distinct, you have something like this, your y and your x. Real and distinct I'm talking about now. So you have a curve like this. You will observe that the curve is touching the x-axis at two different points. So there are real values of x that satisfy the quadratic equation, but they are meeting at different values. That is when you get maybe -2 and 4, for instance, as the values satisfying a given quadratic equation. Sometimes you can have a curve like this, your y-axis and your x-axis, and your curve will appear this way. You will see that your curve is touching the x-axis at only one particular point. In that case, we say that the nature of the root of the quadratic equation are real and equal, because only one point is where it's touching the x-axis. So now let us examine to see the nature of roots of this given quadratic equation. And to examine the nature of root of a quadratic equation, we use the discriminant. D equals b squared minus 4ac. So this b squared minus 4ac is the discriminant that helps us to examine the nature of roots of a given quadratic equation. It is called the discriminant in the sense that it tells us how the quadratic equation will look like. See, when this b squared minus 4ac becomes equal to 0, it means that it will have real and equal roots. Real and equal roots whenever it is equal to 0. Okay? If b squared minus 4ac is greater than 0, it means it will have real and distinct root. Real and distinct root. Whenever it is greater than 0, it has real and distinct root, because it is not 0. And when it is 0, it leaves you with only similar value when you get the square root. So you are adding and subtracting 0. Remember, the quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac all over 2a. Have you seen the discriminant where it is? So when this is 0, the plus and minus is no longer affecting the value we are going to get as x, because 0 is the same thing. But whenever it is a number more than 0, so I'm either, if I'm taking addition, I'm adding 2. If I'm taking subtraction, I'm subtracting 2. So we are getting different values. That is why it is distinct when it is greater than 0. But if it is less than 0, the value here, you cannot get the square root of negative number when it is less than 0. Therefore, it becomes imaginary. All right? So to examine the nature of root of a quadratic equation, we use the discriminant b squared minus 4ac. So let us test and solve this question. For number 1, we have x squared minus 3x minus 2 is equal to 0. My a is the coefficient of x squared, which is 1. My b is coefficient of x, which is minus 3. And my c is the constant, which is minus 2. So using discriminant b squared minus 4ac, let us see what it will give us. B squared means minus 3 squared minus 4 bracket a, which is 1, bracket c, which is minus 2. Minus 3 squared is just 9. Minus 4 times 1 is minus 4. And minus 4 times minus 2 is plus 8. And when I sum, I get 17. So here you see that b squared minus 4ac is greater than 0 because 17 is bigger than 0. And because it is greater than 0, it is real and distinct. Remember what I told you? When it is greater than 0, it means that the nature of the root of the quadratic equation, that it is real and distinct. So let's take the second one. So here we have x squared minus 6x plus 9. Our a is 1, b is minus 6, and c is equal to 9. So we use b squared minus 4ac again. B will now be minus c squared minus 4 bracket a, which is 1, bracket c, which is 9. Minus c squared will give me 36. Minus 4 times 9 is minus 36. And when I subtract, I'm getting 0. Since b squared minus 4ac is equal to 0, it means it is real and equal. Whenever you get 0, it means that the nature of the root of the quadratic equation is real and equal. So finally, let's take the last one. My a is 2, my b is minus 2, and my c is 5. So I'll still use b squared minus 4ac to test. So b is minus 2, I have minus 2 squared, right? Minus 4 bracket a, which is 2, bracket c, which is 5. Minus 2 squared is just 4. Minus 4 times 2 is 8. It's minus 8, and minus 8 times 5 is minus 40. When I subtract, I get minus 36. It's a negative value. And because it is negative, since b squared minus 4ac is less than 0, every negative numbers are less than 0. So whenever you get a negative value, it means that it is imaginary. So no real value of s can satisfy this given quadratic equation. So there are other questions I still want us to solve in this particular video that pertains to nature of roots of a quadratic equation. So let us take them. So in the last one, we have x squared plus k minus 3x plus 4 equal to 0. So we still need to get the value of x for which it will have equal roots. Remember that our a is 1, b is all the coefficient of x, which is k minus 3, and c is just 4. And for it to have equal roots, it means that b squared minus 4ac must be equal to 0 for it to have equal roots. And b is this, so I have k minus 3 all squared minus 4 bracket a, which is 1, bracket c, which is 4, equals 0. So I have that k minus 3 all squared minus, when I multiply, I get 16 equal to 0. Let this 16 come to this side. I have k minus 3 all squared equal to positive 16. Remember, if I have square root, I can take away the square root by squaring both, by taking the square root of both sides. So here, k minus 3 is equal to plus or minus square root of 16 when I take the square root of both sides in order to get the value of k. So I will see that k minus 3 is equal to plus or minus 4 because square root of 16 is 4. So I work with plus after I work with minus. But before that, k is just, when this negative 3 comes here, it's just positive plus or minus 4. So either k is equal to 3 plus 4, which is 7, I'm working with plus, or k equals 3 minus 4, which is minus 1. So it's the values of k are minus 1 and 7 for this particular equation to have an equal root. So if you've enjoyed what you've watched, kindly hit the red button to subscribe to my channel. It will always give you notification whenever we upload a new video. Thank you.